Alright guys, so here's a little bit more of a refined way of finding the x-intercepts and where the graph is positive and negative. The x and y-intercepts, let's do the y-intercept first, y-int, and that is going to equal where the graph crosses the y-axis. This is the y and this over here is the x. And the y-axis is crossed right here at 0, 3, so 0, 3 is our y-intercept. That's the easy part. So is the x-intercept. This one actually has two x-intercepts. The first one is where it crosses the x-axis, which is right here. Happens to be at 3, 0. And the second one is over here at 7, 0. So that's the easy part. Now where's the graph positive and where's the graph negative? And I put the points on here, the ordered pairs, so you can see we're talking about where the y values are positive and where the y value is negative. So if we look across here, on this left-hand side, all the y values are positive up until I hit the x-intercept, which is 0. And 0 is neither positive nor negative. And then once I go past the x-intercept, I get down here, I start getting into x values that are negative, and it stays negative until I come back up to the x-intercept again, and then the values of y all become positive. So in order to do this, what we're going to do is draw a vertical line through each of the x-intercepts, like this. And look at this side. We're going to ignore this right here. We're going to look at this side from this line over. This graph over here is above the x-axis, so this part of the graph represents all the y values that are positive. So on this side of the graph we have positive. Then if we look at the middle section right here, all the dots that are down here are below the x-axis, so all those values are negative on the y values. And then if we look at this right-hand side, all the dots over here are positive again. And you'll notice a pattern here. If it's positive here, once it hits the intercept, the x-intercept, it then changes to negative till it hits the next intercept, and it changes back to positive. Now I have that graph over here again without those numbers in our way, so I'm going to go ahead and draw this again. So we've got our x-intercept there and our x-intercept there. Now remember, this was positive, negative, positive. Okay, so we got all those drawn in there. Now in order to actually write the expression that represents all the positive on this side and all the positive on this side, remember, we're looking at the left-hand side, so it's positive over here when the values of x are to this side of the line. So basically, we're going to treat this like it's a number line. So if we got a number line here, and let's see if we can line these up. Actually, it's over here. So right here, we've got a dot at 3. So a dot at 3. And all this graph right here is to the left of this boundary line, this x-intercept boundary line. So to the left on there, like that. So from here over this way. And then the expression that represents this graph would be all x's that are less than 3. So my graph is positive where all x's are less than 3. Now if I come over here to the right-hand side, okay, we're looking at just this side over here, and that goes at positive 7, so that's a positive 7. So I have a open circle at 7, but the graph is on the right-hand side of that boundary line, which is the x-intercept. So my graph is located to the right, so this one was positive, and this one's going to also be positive, but the graph that, or the expression that represents this graph right here is where x's are greater than 7. So x's are greater than 7. So where's my graph positive? Going back to this one, it's where my, see if I can get both in the picture here at the same time. My graph is positive when x's are less than 3 or x is greater than 7, and this is where they're positive because we broke them up here and we broke them up there. When we go do the negative version of it, the negative occurs in between the two bars. So if we go to the next graph down, like this, we start here on this left-hand side, open circle at 3, but then my negatives end when we hit this 7 over here, so I have an open circle at 7, And it's negative everywhere in between. So now we're going to draw and connect our lines like this, and then we just write an inequality to represent that. Remember, the line itself is the x value. Well, the number over here is 3, the number over there is 7, and all the x's along this value right here, or this part of the graph, are somewhere between 3 and 7. So we would say 3 is less than x, which is less than 7. And the way the book explains it is to say that it is negative when x is between 3 and 7. And another way of expressing it is just to show 3 is less than x is less than 7, where x is between the 3 and the 7. And that's how we define our positive and negative. So if we go back to the other graph, the graph is negative when we have x's that are bigger than 3. So remember, it's in this region right here. Bigger than 3, but it stops at 7, so less than 7. And the reason we don't have any equal signs at these is because at the x-intercepts themselves we have values of 0, and 0 is neither positive nor negative.